Welcome to my channel. I'm Jody, and on this channel it's just you, me, and math. Today we're going to be talking about fractions, but specifically adding and subtracting fractions. I'm not going to go over multiplication and division. That can be for another video, but I really want to get into addition and subtraction, considering that's generally the operation that is the hardest when it comes to fractions. Now, I'm also not going to get into variables and fractions. Today it's just numeric, but I can do as many videos as you need with variables, with equations, things like that, because fractions are such a huge topic. So let me know in the comments below if you want me to cover any other types of fractions, proportions, word problems definitely is a big topic. Any of those things, leave any suggestion you want of whatever topic you want me to cover in the comments below. I have a running list on things that I want to cover, and I'm going to continue on that list with things that you add as well. So I hope that you'll subscribe, I hope that you'll come back, and I can't wait to go over fractions with you, and hopefully it'll make more sense at the end. So without further ado, let's have some fun. Or should I say, let's have some fun. Not some as in a little, some as in addition. The math puns will be plenty on this channel, so expect them and call me out on them and suggest your own. We're going to have some fun. See, I even said it then without meaning to. So welcome to my life, welcome to my channel, and I can't wait to get into it. What I'm going to start with is a quick review on some of the do's and don'ts and some of the rules and just quick conversions that you're going to need throughout today. And so without further ado, let's do it. All right, so a little review first. I wanted to go over terminology and try to come up with ways that you can relate fractions to your real life, because I always hear so many times like, when am I going to use this in my real life and all of that. Fractions are one of the things that are everywhere in real life instead of this little math bubble that we're sitting in right now. So in terms of a fraction, the mathematical terminology would be that the top is called the numerator, the bottom is called the denominator. Now, something that can help put it into perspective is you can think of it as parts out of total. So if you ever in a word problem, or if you ever just in speaking say or see the phrase out of, that's a pretty good indicator that you're speaking about a fraction. For example, if I have this pizza and someone eats these 3 pieces, now there were 8 total, then that person ate 3 parts or 3 pieces out of the 8 total pieces. But you could say it's a numerator 3, denominator 8. But you ate 3/8 of the entire pizza. So this phrase right here I think is underutilized, but it comes up often in word problems or story problems. Those do have differences. But if you see those, think, oh, it's a fraction, or any type of proportion or ratio or comparison between things. Fraction. So you really want to make sure to get your rules down, because fractions are everywhere. So 2 very common types of fractions that we'll want to learn how to convert in between, back and forth between, thus this kind of double-ended arrow, is a mixed fraction. You would see a fraction like this maybe in cooking. Maybe you would measure out 3 2/5 cups of flour for a certain recipe. However, an improper fraction, that's when you have the top that's bigger, it's top heavy, it's got a bigger numerator. This isn't something you would probably see in a recipe book. You wouldn't measure out 37/5 cups of something necessarily. What you would see instead is you would see its mixed equivalent. So a quick refresher here, let me know if you want a more in-depth video, but this is how you convert between the 2 forms. So to go from a mixed fraction into an improper fraction, you go around the world. So you start with this 5, always start with the denominator, and you're going to multiply those 2. Then you're going to continue, so there's your full revolution around the world, and you're going to you're going to add right here. So you're going to do 5 times 3 and then plus 2. So 5 times 3 is 15, 15 plus 2 is 17, so that becomes your numerator of the improper fraction. Now your denominator will never change, whether going this direction or this direction, your denominator will always stay the same. So 3 2/5 of anything is the exact same as 17/5 of anything, but this in real life is a bit more easy to handle because it's a lot more familiar. However, in math, generally, improper fractions are easier to deal with because there's only one part here. There's not a whole number part and a fraction part. That can get a little bit confusing depending on what you're doing, but these are generally going to be easier to deal with in math problems. So if we want to go back the other direction, what we would do is essentially long division. So we would take 5 into 37. Now, if you're ever not sure which number goes inside when you're making a division problem, I always use the phrase, the top dog gets the house. So the one on top, the top dog, he's number one, he's most important, he gets the house. So he gets to go in the house. Or you could just tip the fraction over like that. So whatever helps you to think about it, but top dog gets the house is kind of a good little way to think about it, I think, and it tends to stick. So we would say, okay, 5 goes into 37 7 times, and we would say 5 times 7 is 35, and then we would subtract. And then we're basically done with our division. So this number right here is how many whole times it goes into 37. So that turns into your, didn't leave myself enough room. We're going to put it right here. So it would be 7 whole times. And then this is the remainder. So since that's the remainder, that's what's going to be on the top of our fraction. Because remember, the denominator has to stay the same. So it does have to stay as a denominator 5. But this remainder, that's going to be the top of your fraction. So if you ever needed 37/5 of anything, you need 7 2/5 of whatever that is. So I hope that makes sense. Let me know if you want a little clearer explanation or more, maybe not clearer, but more in-depth explanation, and I'm happy to go into it. Let's do a little bit more. Something else that's extremely important when you're dealing with fractions is to make sure your solutions are always reduced to what's called lowest terms. Now these fractions are going to be equal or equivalent fractions, so they'll represent the same amount of stuff, if you will, but you need to make sure you're always reducing final solutions all the time, which is obviously what always means. So especially now where a lot of math has been online, a lot of classes have been online, and a lot of platforms, you will hand type in your solutions. If you type in, for example, 4/8, you could be marked incorrect. When you're not wrong, it just can be reduced smaller. So what's really important about reducing is what you do to the top, you do to the bottom. So you always do the exact same thing to the top and the bottom. However, you need to make sure that you are only ever dividing on top or bottom. You can also multiply, but we won't be in this situation. But you can never, no exceptions, ever add or subtract something from the top and bottom. So you cannot, for example, just subtract 4 and subtract 4. Never going to work. So instead what we want to do is find a number that you could divide both of those by, and again, both of them. So the least amount of steps would be to find the biggest number that you can divide them both by. So in this case, we would be dividing by 4. So that is going to leave us with 1/2. So see, if you think of this in terms of a pizza, if a pizza was cut into 8 pieces and you ate 4 of them, 4 out of 8, as we talked about earlier, that would be the exact same amount of pizza had it only been cut into 2 big pieces and you ate 1 of them. Same amount of pizza, but smaller numbers here. So this is the answer you're going to be looking for. Now, same thing happens here. If you can find the biggest number to divide them both by, then that's going to be less steps. But I'm going to show you what happens if you pick a smaller number. It's not wrong. You just may need to go a couple more times. So for example, let's say you know for sure that you can divide both of these by 2. That would leave you with -6/20. But inspecting this shows that that's not in lowest terms. So what we can do is go again. You don't have to go back and start over from the beginning. You can, but you don't need to. You just need to keep on going. In this case, we're going to divide by 2 again. Keep on going until you can't go any further. So this would be the lowest terms form of these two. These are all equivalent fractions. Again, it's important to note that they're the exact same fractions. They represent the same amount of stuff. So you can use either one of these in any problem that you want, but it's generally easier to work with smaller numbers, so make sure to always reduce. And again, only division, not addition, not subtraction, ever. All right, off my high horse for a minute anyway. Now there are a lot of times when you're dealing with fractions, but you're thrown a random whole number. And you kind of are thinking, well, where's a numerator and a denominator on that? So this is actually pretty straightforward. To make any whole number into a fraction, all you do is put it over 1. Because, for example, I don't know if you've ever thought about it, but a fraction bar can be thought of as a division bar. We kind of did division earlier, but watch this. So if you think of it as 5 divided by 1, well, 5 divided by 1 is just 5. So that means you can write 5 as 5/1, and these are equivalent. Well, of course, these are equivalent, 5/1, but 5/1 and just 5 are equivalent. Now, the opposite way would not be true. If you had 1 over 5, that is not just 5. Sometimes I'll see students try to say, oh, well, that equals just 5. But this is like saying 1/5 of a pizza. This is like saying 5 pizzas. So that's not the exact same. But the moral of that long-winded story was to make any whole number a fraction, just put it over 1, and you have a numerator and a denominator for any operation that you need to do. So before we actually get into the topic of addition and subtraction, I want to go over a couple very important do's and don'ts, and then we'll get into it. Reducing is extremely useful, but you have to know when you're allowed to and when you're not allowed to. You can't just start canceling stuff willy-nilly and going crazy with it. You have to know when it's actually allowed. So for example, here, do reduce vertically before and after, meaning before you start the problem and after you're done. You don't have to reduce beforehand, but at the end definitely do. However, if you do reduce beforehand, it does make your number smaller, a lot more manageable. So for example, on this guy here, I could just add it together as it sits. However, I'm getting some big numbers here, 12 and 5 and 10. So to be able to put all those together, though it's not impossible, it's a little harder to keep track of. So if we wanted to, we could reduce the -5/10. We can divide both of these by 5, and that becomes -1/2. You could do the same with the 9/12. We can reduce both of those by 3, so then it's adding 3/4. So this is going to feel a little bit more handleable because the numbers are smaller. Now, again, so once you reduce both of these vertically, you just end up with -1/2 plus 3/4. The answer to this problem is the same as the answer to this because they're equivalent fractions. This isn't something you have to do, but very, very useful. Now, something you cannot do is reduce diagonally or horizontally with addition. Again, not getting into multiplication and division today, but with addition and subtraction of fractions, you cannot reduce diagonally. For example, the 6 and 24, cannot do that. Cannot reduce the 2 and the 10, nope. How about the 24 and 10? No. 2 and 6, no. So this is something that I want to show you, but don't do it. So for example, if you were to divide both of those by 2 and divide both of these by 6, that is illegal. That'll put you in the math jail. There's no such thing, but if there were, you'd be in it because you cannot reduce diagonally or horizontally when you're adding and subtracting fractions. But vertically is always okay. But I would say when in doubt, don't do it. If you're not sure if you can reduce, don't do it. Reduce at the very, very end and you'll be good as long as you wait till the end. But generally, vertically okay. Any other way, not so much. So let's actually get into the addition and subtraction. I'm going to give you a bunch of examples, work through them with you, and I hope that you'll leave any questions that you have down in the comments and I can address them. The most important thing when you're adding and subtracting fractions is to have what's called a common denominator. That means the denominators of your fractions need to be exactly the same. Now I'll show you why you can't add them when they're different in a minute, but why do they need to be the same? So let's go back to the pizza example I used earlier because it's relatable. So let's say we have 3/8 of a pizza. So I'm going to split this pizza into 8s. So someone's going to eat 3/8, so that would be this much. And then someone else comes along and eats 4/8. Now this is going to be really easy to mark off in the pizza because this is in terms of 8 and this is in terms of 8, so same size of slices. So now I'm going to mark off 4 pieces out of 8, 4 additional pieces. So once you inspect the pizza now, how much has been eaten total? Well, if you're just looking off of the picture, you would say, well, there's 7 pieces that are colored in or 7 pieces that are eaten out of, again, the out of, the fraction indicator, 8 total. So from the picture, it appears the answer should be 7/8, and that is the correct answer. But how do we find that from here without having to draw a picture every single time? So once the denominator is the same, leave it the same. So once they're both 8, leave it an 8. When they're common, leave it alone. What you're going to be doing is adding or subtracting the numerators of the fractions. So you're just doing 3 plus 4, and that's what's going to go on top. So I hope that illustrates why your denominators need to be the same. For example, what if this had been 4/7? How would I color in 4/7 on this same pizza when it's cut into 8ths? That's why it's very difficult to visually show fractions when they have different denominators, because you need them to be cut into the same amount of slices, and then you can easily add or subtract them. Now, if we're subtracting, same thing. We've got our denominator already the same, so we're going to leave that as an 8. Then we're going to subtract. Notice I kind of dip down and include the sign here. You can also write it like this. Write whatever the exact numbers are on top and then solve it from there. So we end up with 4/8. So when you're subtracting, we come up with 4/8. Now, 4/8 is actually the answer, but it wouldn't be considered all the way done because it's not in lowest terms. So make sure to divide the top and the bottom by 4. And your final solution would be 1/2. So this one is in lowest terms, this one is in lowest terms, so we're good to go. So those two examples illustrate why the denominators need to be common. Let's do some examples where we need to force those denominators to be the same. So how do I make denominators become common? So if you think back to the pizza example, how do I color in 2/7 and then also 5/3? What we're going to think instead is, how can I make those denominators be the exact same number? So our goal is to find a number that 7 and 3 both will go into. Another way of saying that is, we need to find a number that's divisible by both 7 and 3. One way you can do this is just start listing the factors of 7, well, not the factors, the multiples of 7, or just count by 7s and then count by 3s, and the first number you come to in each list that's the same, that's going to be your common denominator. So for example, if I count by 7s, I'll be going 7, 14, 21, etc. If I count by 3s, I'll have 3, 6, 9, 12, 15, 18, 21. So since I've reached 21 in both lists, that's the number I'm going to make both my denominators become, and then they're going to be common, and then we can add them. So what we want to do is, remember what I said earlier, what you do to the bottom, you do to the top. Never adding and subtracting, only multiplying or dividing. So to make this 7 become 21, what I need to do is multiply that by 3. Another way to think of that is there's 3 numbers here. So you multiply that by 3. And apparently you need to do the sound effects too. So whatever you do to the bottom, you do to the top. So we're going to times that by 3 as well. So what we're going to have here is 6 over 21. That's an equivalent fraction of this one. Now I need to make or figure out how to make 3 into 21. So I need to times 3 by 7. And you can tell because there's 1, 2, 3, 4, 5, 6, 7 numbers here. And times by 7 here. Now this can get pretty tedious listing out the multiples, but if you just can't figure out what numbers to use, that is always a good tactic. So we're taking 6 over 21 plus, this one becomes 35 over 21. And then you just add your numerators and leave the denominator alone. So 6 plus 35 is going to be 41. So 41 over 21. Do a quick check to see if there's anything that you can divide both of those by. There's not. So that is your final solution on that. So again, find a number that your denominators can both be made into. One way that will always work is you can just times these numbers together. Now that's fine and dandy when the numbers are pretty small, but if you had numbers such as maybe 24 and, I don't know, 72, it might be easier to think, oh, instead of doing 24 times 72, start listing out the multiples or count by those numbers and figure out what number comes up in the list. So let's see what happens with this one. So 5 and 4. If we count, we do 5, 10, 15, 20, 4, 8, 12, 16, 20. So we're going to use 20 as our common denominator. And if you use the first number that comes up common in both, this is actually called your least common denominator, often abbreviated as LCD, least common denominator. But you don't have to use the smallest number. If you wanted to, you could make 5 and 4 both become 100. It doesn't matter because your answer will still be correct. You just may, if I could speak, you just will need to reduce at the end if you don't use the least common denominator. That's what I was trying to get out. All right, so let's make both of these denominators become 20. So on this one, I need to multiply the top and the bottom by 4. So I'm going to have negative 16/20. And I need to multiply the top and the bottom here by 5. Again, make sure that whatever number you pick, you do the same on top and bottom, so long as our denominators become that number that we're looking for. So then we're going to say that's plus negative 15 over 20. So combining those numerators, negative 16 plus negative 15, when you're adding two negatives, you're getting further into the negatives, so you'd add the numbers together. 16 plus 15 is 31. And then you'd keep the negative on there. So negative 31 over 20. I can touch on negatives extensively in another video if anyone's interested. Let me know. But for now, when you're adding two negatives, add the numbers themselves and keep the negative sign. And then you're good to go. This can't be reduced anymore, so we're in lowest terms. So I hope that this helps. Now, again, writing out these multiples here can get fairly tedious, so I'm not going to do that on these ones coming up, but I hope that that gives you a way of writing things out, especially for those of you who are very visual and like processes. This process will always help you find it. So let's do a few more examples. Two more examples here. Remember something that I was saying earlier, especially on this one. Where can we reduce? Vertically, if we want to. So I can reduce this and I can reduce this. But where can I not reduce? Diagonally, so I can't reduce the 6 and the 12, or horizontally, so I can't reduce the 12 and the 20. Now again, when in doubt, just don't do it. Don't reduce until the very, very end if you're not sure if you can. But if you're confident that you know the rules correctly, then you can reduce beforehand. So I am going to do that. I'm going to reduce this one and divide each one by 2. And I'll reduce this one and divide each of these by 2. So I will come up with negative 5/6 plus, said 6 and write 5. Good job, self. Pat on the back. Plus 3/10. So negative 5/6 plus 3/10 is now what we're adding. Now again, the answer to this will be the same as the answer to this because these fractions are equivalent to these fractions. But rather than have to find a common denominator between 12 and 20, which would be 60, but who wants to deal with those huge numbers? Why don't we figure out a common denominator between 6 and 10? And that can be a lot easier number to stomach. Now 6 and 10 will both go into the number 30. So again, think of it as 30 is divisible by both 6 and 10. So let's make both of those denominators become 30. So I'm going to write this one underneath so you can see how this is going. This is always a good technique if you want to just do one number or one step at a time. Say, okay, I know 6 and 10 go into 30. So my goal is to make my denominators become 30. So if you write where you know you're headed and then make that happen, it's less to keep track of in your head. So how does 6 become 30? Again, through multiplication. No addition there. You want to multiply the top and the bottom by 5. What you do to the top, you do to the bottom. So negative 25. And then multiply these by 3 because that will make the denominator 30. So we have negative 25 30ths plus 9 30ths. Now again, something that I want to mention here is if you want to reduce here, you can. However, then you're going to kind of go backwards to this step. So I like to reduce either before we've started or at the very, very end. Okay, but not kind of in the middle, though it's not wrong. It's just going to take you kind of in a loop and you'll realize you're back where you started. But that's okay. Now, let's add these together by taking negative 25 plus 9. So negative 25 plus 9, that's actually going to be negative 16. So this is going to equal negative 16 over 30. The benefit of a movable board here. Now, notice that this is not reduced to lowest terms. We actually need to divide both of those by 2 because our final answer in every fraction problem you ever do needs to be in lowest terms. So let's divide both of those by 2, and we're going to come up with negative 8 over 15 as our final solution on that. So again, as a recap, you can reduce vertically at the beginning and vertically at the end, but never diagonally, never horizontally. I can repeat it many, many, many times. You need to get that in your head because very, very important rules here. All right, so because I have 5 minus 3/8, let's use the rule we spoke about earlier when we can make any whole number into a fraction by just putting it over 1. So now it's saying 5 over 1 minus 3 over 8. So looking at those denominators, 1 and 8, what can I make both of those become? 8, right? So we want to say, okay, I want both of these to become something over 8. Now this one already is over 8. So I'm just going to copy that. But something you could do is you could say, oh, well, I just want to multiply the top and the bottom by 1. It's nice to see in your brain that you are multiplying by something, but it does end up with the same fraction anyway. So let's multiply this one by 8. So that is going to be 40. Now again, 40 over 8 is the exact same quantity as 5 over 1, but this makes it so our denominators are the same, so we're able to, well, subtract them in this case. So let's subtract those numerators, 40 minus 3. Remember, you can write it like this, and then your answer would be 37 over 8. Now that cannot be reduced any further. It's already in lowest terms, so you're golden. I hope that makes sense. Make any whole number into a fraction by putting it over 1, and then continue on from there. These are the last two examples. I wanted to do a couple of mixed fractions and also one where you had 3 fractions so that we could talk about the differences between these. Now on this one here, if you want to add or subtract mixed fractions and keep them in mixed fraction form throughout, you can absolutely do that. That's not a problem at all. There are definitely some things to keep track of and some things to go over. So if you want a detailed video, again, drop it in the comments. My list is long. It's going to keep getting longer, but I'm excited about that. So anyway, if you want me to go over those in depth, let me know. But my suggestion is if you're adding mixed fractions, change them to improper fractions. It's difficult to deal with mixed when adding and subtracting sometimes because you have whole number pieces and fraction pieces. So how do those go together? Well, if you can just make each one into one single fraction, one single improper fraction, it's going to be a lot more smooth. So 3 1/3, remember, we're going to go around the world where we multiply here and add here. Same thing here. And that'll give us 2 improper fractions, a lot easier to deal with. So 3 1/3 is actually 3 times 3 is 9, plus 1 is 10, so that's going to be 10/3. And then 5 times 2 is 10, plus 3 is 13 over 5, so 13/5. Remember that your denominators need to remain the same, going from mixed to improper. So these fractions are the exact same as these fractions, but they're in an improper form. So now if you look at these, you just want to say to yourself, what do 3 and 5 both go into? Now 3 and 5 will both go into 15. So let's force both of those denominators to be 15. So like I said, let's keep track of that by writing that down like this. And then you just say, well, how do I get there? How does 3 become 15? Well, you would need to multiply by 5. What you do to the bottom, you do to the top. So 50/15 is the exact same as 10/3. It doesn't look the same, but if you were to reduce it, it does become the exact same. So on this one, we need to times this by 3 to make it 15. Times this one by 3, so that's 39. So 50/15 plus 39/15 gives us our final solution of, adding the tops, 89/15. And that is fully reduced. There is nothing that you can divide both of those numbers by, so we can walk away. So again, I do prefer to make these into improper fractions generally, but sometimes you need to keep them in mixed form. Sometimes you're directed to keep it in mixed form, like that's the whole point of the lesson. So I'll be happy to go over that if any of you guys are interested. But let's go on to one with 3 fractions here. Now, you don't need to solve these separately. For example, sometimes people will try to add these together or subtract and then do the answer to that one with the third one. And while that is correct, it's more steps than necessary, I'll say. So let's instead do all 3 of them together. We want to find a denominator that 9, 3, and 2 can all be made into. So again, either list out the numbers or do it in your own brain, but 9, 3, and 2 can all be made into 18. So let's keep track of the goal here. We're going to make each of them into 18. Notice I copied the signs as well. So I'm going to make 9, 3, and 2 into 18. So ask yourself, how do I get there? So for 9 to become 18, we need to multiply by 2. Do to the bottom, do to the top, so that's 14. Now, if you're not sure if you did this part correctly, going from here to here, reduce this fraction and see if it becomes 7/9. It does. We're good. So let's multiply this one by 6 on top and bottom. So that would be 12. And then multiply this one by 9. So that would be 81. So again, these three fractions are equivalent to these three, so they're going to give us the same solution, but now we have our common denominator, so we can add them together. So we're going to do all three of these. Notice, again, I kind of dip and include those signs because if you draw through them, it's easy to lose them. So 14 minus 12 is 2. 2 plus 81 is 83. So 83/18 is our final solution, and we are golden. So I hope that that has made sense. I hope that fractions are not going to feel quite as scary, but really what it comes down to is just doing as many of them as you can do. It sounds kind of silly, but you want to get to the point where you're almost bored with it in the way that you've done so many that it's easy now. You don't want to get to it and be like, oh man, another addition or subtraction. Hopefully you get to the point where you can just say, oh yeah, that's no problem, common denominator, I got this. So do as many examples as you can, and I hope that this video was helpful. So let me wrap it up here. Thank you so much for watching the video. I hope you made it to the end. If you do, bravo, because sometimes I think I can be a little bit long-winded, but I just want to tell you all the things. I really want it to make sense. Adding and subtracting fractions is something that's so common in so many different topics within math throughout your whole life of math, that it's something that you really want to make sure that you master. So let me know how I can help. Again, questions, comments, suggestions of topics, put them in the comments. Please subscribe and please come back. I would love to see you again. So hopefully, see you soon. Have a beautiful day.